You are going to write your first Python program soon. It will be something small, a loop, maybe a function that calculates something trivial, and then you'll feel nothing. Not because the code is boring, because most Python tutorials skip the actual reason you are learning this. They hand you the syntax to memorize and call it done. You memorize a for loop, you understand a list, you miss the entire point. So we are not starting with code today. We are starting with something more fundamental. Setup, mindset, and the foundation that makes every program after this one actually matter. Here is what I notice when people learn Python. There are two paths. The first path is additive. You collect syntax rules like trading cards, variables, then loops, then function, then classes, each one another rule to remember. By week 6, you are drowning in details and you never quite see how they fit together. The second path is structural. You learn how to think about problems first. Then you use Python as a language to express those solutions. For data science, you are in that second group. Whether you know it or not, you are not learning a language, you are learning to communicate with data. That requires a completely different starting point than a web developer or automation engineer uses. Let me show you why the structural approach matters and how to set yourself up for it. Your Python environment is the difference between I learned Python and I can actually use Python to think clearly about problems. Most tutorials tell you to install Python, maybe pip, and you're done. For data science, that does not work. You need isolation. You need reproducibility. You need to know exactly what version of what library you are using. Because a bug you might have today disappear when you upgrade something next month and you need to trace that. Bad environment setup is why most people's first data science projects fail silently. The code runs, you get an answer, but you can't recreate it. You can't extend it. 6 months later, when you need that analysis again, nothing works. Here is what actually works. Install Python 3.11 or higher, 3.12 if your library is supported, and then immediately create a virtual environment. For this tutorial, I will be using Python 3.14. So if we open up the terminal, you can see my Python version. It's 3.13, not 3.14. Now I'm going to make a directory, uh, not a directory, but I created a file hello.py. But before we even do anything in that file, what I want to do is create a virtual environment. So to create a virtual environment, you need to run the command python space -m venv and env. So venv tells you it's your virtual environment, env is your environment name. Now you can see that environment folder got created, and after this you can activate the virtual environment by typing the command source env bin/activate. So you can see here earlier it was base, now it says Python course. So we are now working in the Python course virtual environment, and this source bin activate line, that's the most important line in your Python journey. Every time you sit down to code, run it, your environment will stay clean. No accidental global installs, no version conflicts. Install one thing uh, for now, which is Jupyter Notebooks. That's where you will learn Python for data science. So to install Jupyter Notebook, you can run the command pip install Jupyter, and it will install Jupyter Notebook in your system. I'm telling you this because I learned this the hard way when building AI and data projects across different environments, local machines, Docker containers, cloud notebooks, even managed runtimes like Databricks. One project worked perfectly on my laptop and completely failed inside a container because the Python version and the dependency tree did not match. Another time, a subtitle generation workflow broke because a library update silently changed behavior between environments. I did not lose time because Python was hard. I lost time because the setup was sloppy. That's when I stopped treating environments like optional cleanup and started treating them like part of the actual engineering. Before we write a single program, we need to talk about how to think like a programmer. There is a difference between running code that works and understanding why it works. Computational thinking has four parts: decomposition, break a big problem into smaller pieces. Instead of analyze this data set, you break it into load the data, clean it, explore it, find patterns, visualize results. So rather than saying analyze the data, it becomes load the data, then clean it, then explore it, then find patterns, and then visualize results. Pattern recognition, you notice that similar steps repeat. So you load the data the same way each time. Abstraction, instead of writing the same code 50 times. So abstraction means you convert it into a function. Instead of writing the same code 50 times, you write it once, you name it, and you reuse it. So you know what you need, how you will do repeated parts, and where to reuse solutions. You have a sequence of steps. That's your program. So here is Python's syntax does not teach you this. A tutorial starting with print hello world does not teach you this either. But every line you write from this point should reflect this structure. One of the biggest shifts in my own work happened when I stopped asking what code should I write and started asking what are the actual pieces of this problem. I remember building workflows around long form content repurposing, turning videos into subtitles, clips, structured posts, and metadata. At first, it felt overwhelming because I saw it as one giant system. But once I decomposed it into stages, extract audio, generate transcript, clean text, identify highlights, render captions, export formats, the implementation became straightforward. Most programming becomes easier the moment the problem stops feeling like one giant blob. Now we will write code, but we are not writing hello world. We are writing a script that touches data. Create a file as I've created here, hello.py, or anything that you want to name. Then we will import something called JSON. So JSON is a data type. It stands for JavaScript Object Notation. And then we define some data. So to define some data, we have this list of dictionaries. So this is a dictionary in Python that is enclosed in curly braces, and a list is enclosed in square braces. And then we want to calculate total average. So for this people list, to calculate total average or calculate average age, so we define a variable called total age and initialize it with 0, and then we loop over our people list and we sum total age and for average age it will be total age divided by number of people, and then we are going to output this. Now we are going to save these results in a file. To save these results, we are first going to convert our data into a dictionary or a JSON, you can say. So here are a few things that you should understand first. So, but before I even explain it to you, let me run the script. So you can see average age is 35, total number of people 3. So there are few things that are maybe not straightforward to understand. First is in this print statement, there is something called f. So if before a string in Python, if you put f, it's called an f string. And using curly braces, you can directly put variable values inside that f string. And here in average age colon 0.1f, it means one value after decimal. And then we are writing to file. So this is the file name, as you can see here. If I open it, you can see average age is 35, total count 3, where W is the mode in which we are opening the file. So you will see output now in your terminal, right? And as I mentioned, the file results.json with results. So here are a few things to notice. First, you are working with structured data. Structured data means this people variable, it's a list of dictionaries and not strings. That's the data science part. Second, you are using a loop to accumulate a result. So here in this particular scenario, you are using a loop to accumulate results. You will do this thousands of times in data science, iterate, calculate, and collect the results. Third, you are saving your output in a reproducible format, JSON. So JSON is a quite good reproducible format. You are saving your results there. This matters because next time you run the script, you can reload this file and extend your analysis. This is a real program, not hello world, a working piece of thinking. This tiny script already contains the structure behind real world data systems. Input data comes in, as you can see, then transformation happens, the logic runs, and then the output gets stored somewhere. All of this is reproducible. The scale changes later. Maybe the data lives in a warehouse, maybe Spark processes millions of rows, maybe an API triggers the pipeline automatically, but the mental structure of the code stays surprisingly similar. That's why learning small scripts properly matters more than jumping into advanced AI tutorials too early. The foundations scale farther than people think. Now, the one skill that matters the most, reading error messages. You are going to write broken code today, tomorrow, forever. The only difference between someone who learns Python and someone who gives up is how they respond to errors. Most tutorials do not teach this because it's not glamorous, but it is the skill that compounds. Python gives you error messages, they are helpful. Let me show you how to read them. So in the line where we are totaling the age, we change it to, instead of age, we change it to ages. And then if we try and run it, you can see error, key error, ages. This is how to read it. Key error, the type of error. Key error is the type of error. Python is saying you try to access a key that does not exist. Ages, the specific key you try to access. Now you know I misspelled something and that's caused the error. And now if you fix it again, you run the program, it executes. Now it is obvious when it's a typo, but in real data science you will get errors like value error. So let me write it for you. So value error, could not convert string to float, or index error, list index out of range. The process is the same. Read the error type, identify what went wrong, and fix it. Most of your learning will happen through errors. The people who give up are the ones who see an error and think, I'm not smart enough for this. The people who succeed treat errors as feedback. What did I do wrong? How do I fix it? Run your code when it breaks, and it will. Read the error carefully. Google it if you don't understand it. Fix it, run again. Percent of programming. Now the takeaway for this tutorial is you now have an isolated environment where you can code without breaking anything, a mental model for breaking problems into pieces, your first real program, the one that reads data, calculates something and saves the result, and a way to debug when things break. You don't have a lot of syntax memorized yet. You don't need to. You have something better, a foundation. Everything in the remaining tutorials in this series build on this structure. You will learn functions so that you can reuse patterns, classes so you can organize complexity, libraries so you can stand on the shoulders of people who solved these problems before you. But none of it matters if your foundation is shaky. Come back to this when things feel overwhelming. Rerun your first script. Remember that it worked because you set up your environment correctly and broke the problem down into pieces. That's all programming is. Run your script, make sure results.json get created, reply with what you broke first, and everyone breaks something. The fact that you broke it and fixed it, you means you are learning correctly. Now ready for tutorial 2? We'll build on this foundation. Same structure, thinking first,